So, today discuss about some of the computing paradigms. More specifically, today we will discuss about DIU computing paradigm, which are some of the related cloud computing related computing paradigms. So, in this thing what we will discuss about that overview, or what is the basic concept of this DIU computing, what are the basic features, this different type of applications, and a broad architecture of the DIU, right, and definitely also will end up with the type of challenges DIU computing is facing, right, or what are the different challenges out there, right. So, if we see your today most of us are used with different type of services, like one of the popular services is Dropbox, right, where we use as a storage for primarily for storage purpose, and we have also experienced whether the whether there is a internet connection is there or not. Your Dropbox folder is primarily synced is available for your purpose and at a local level, or in other sense it is a something as a storage as a service which is synced with that in the with the cloud or storage wherever the Dropbox is there, but it has also a local instance, right, or what we say which is which can be accessed even if the connection is not there. So, rather if you those who are working with cloud computing, somewhere or other we have all have experience of this cloud compute thing. So, one of the major challenge is the this your reliable or continuous uninterrupted internet connectivity. If the connectivity is lost, then you cannot able to do something, right, do your work. So, DIU is try to have. So, Dropbox is an example of DIU computing, where you have a local instance. For that matter, what we say some sort of a local sort of a DIU virtual machine is installed in your systems, which not only allow you provide you services, whatever the services provides, for in case of Dropbox the type of data level services, and also it sync with the cloud as and when it gets the connectivity, right. So, so if we look at the overall big picture of the computing paradigm taken from this particular paper, so the internet is the binding things, right. So, though the major this paradigm is the cloud computing, but there are different allied paradigm like mobile ad hoc computing, fog computing, edge computing, cloudlet computing, mobile cloud computing, mobile edge computing, and of course, there is a concept called DIU computing, right. So, we will be looking into little bit more into this DIU computing paradigm, how things works, right. So, but nevertheless, for all these scenarios, what we require is primarily is this reliable or constant network connectivity. If the connectivity is lost, then we face a problem in getting the services for that particular purpose or particular activity application areas. Now, DIU computing, also referred to as this, has different perspective, or you can see that if you find the literature, there are different way of looking at it, right, though the basic philosophy is same, but different. So, it is a computing paradigm that combines the core concept of cloud computing definitely with the capability of the end devices, right. So, personal computers, mobile phones, etc. So, which comes at the end devices, try to leverage on the this capabilities of the end devices, right. It is used to enhance the experience of the end user in comparison to only using the cloud computing. So, say I have, like if you again refer to this our Dropbox example. So, the storage could have been in the cloud, I get the connectivity, I work on the things, right. So, that has requires a constant connectivity, and but I have that thing, if I have a some sort of a virtual instance of that Dropbox in my system, or having the, so what I can do, I can still work on the thing, whenever this whenever the connectivity is there is sync, right. So, it goes on syncing with the backend cloud infrastructure, right. So, it enhance the experience. So, it is rather gives more smooth experience to the end user, right. And the name suggests also, from the cloud is far above, then we come down to something called fog, and then when we come to the dew, we are basically at the ground level, right, or at the device level. So, dew computing, as we were discussing, attempts to solve one of the major challenge in case of a cloud computing thing is that reliance on this network access. So, constant or ubiquitous uninterrupted network connectivity that we can get rid of, right, or we should not say get rid of, even it works when the connectivity is not there, right. So, let us see that what are the different way of looking at it. So, it is a computing model for enabling ubiquitous, pervasive, convenient, ready to go, plug-in facility, empowered personal network, and include single hyper hybrid peer to peer communication link, right. So, I can have one kind of communication link with the rest of the world or the cloud, but however I can work out here. So, primary goal to access a pool of raw data equipped with metadata that can be rapidly created, edited, stored and deleted with minimal internet management effort. That means, can be also done with in a offline mode, right. So, that is one of the primary goal. So, also to utilize this all functionalities of cloud computing, network users are heavily dependent on the network connectivity of that time, which dew computing tries to facilitate, that even without network connectivity things can work. So, little bit jumbled up, means too many lines on this slide, but let us go a little slowly and try to have the whole thing in a bundle, right. So, it is a paradigm which is user centric, right, and highly flexible and personalized supported applications are prioritized, right. It is located very close to the devices, right, or end devices, and it is the sort of a looked as a IoT fog cloud continuum, right. So, it is if we see the IoT fog cloud continuum. So, it is the first thing from the user end which you attempt to interact with, right. So, it is a microservice based computing paradigm, rather in several literature they primarily focus on these aspects with vertically distributed hierarchy, right. You have a hierarchy things on the up in the ladder. So, it comprises of smart devices, like it can be smartphone, it can be smart watches, it can be tablets, and even our laptop and other devices located at the edge of the network to connect to the end devices, right. Collect and process IoT sense data and offer other services, right. The services in dew are relatively available and it is not mandatory to have permanent interaction. So, the dew services are mostly always always available, and you may not have always the network connectivity, right. So, in other sense allows you to work when the connectivity is not there. It is not to be seen that without connectivity you still sync, etc. So, that it requires, like those who have used things like Dropbox, Google Drive and type of things, you have seen that it still require you need to sync the data, right. So, DC is a microservice based, which means that it does not depend on any centralized server or cloud data centers, right. So, it is one of the other thing is that it is a microservice based operation. So, it does not depend on any centralized control or DC cloud DC type of things, right. Though it requires to sync with the this cloud infrastructure or cloud data center, but it is not dependent on fully on that. So, DC does not rely on centralized computing devices nor a permanent network connectivity to work on, right. So, typical example, as we are telling, Dropbox is an example of the due computing paradigm, as it provides access to the files, folders in the cloud, in addition to keeping copies in the local device. So, whenever the connection is not there, then also user can access those, right. Allows the user to access files during times without an internet connectivity. When the connection is established, again the files folders are synced back to the cloud server. So, that is the thing, and those most of our are used to this type of system. So, we can have this type of paradigm which allows you to work when the connectivity or the cloud connections is not there, right. In some cases, it also so happen that it is not only that connectivity is lost, it may save your energy in a or overall costing in a big way, because you don't want to connect, you want to work, and then you connect when you get a favorable connections or high bandwidth connections, things like that, right. So, you do not have to be always connected with the things, right, with the cloud backend. So, it is obvious the key features are independence and collaboration, right. Like if you see in case of a Dropbox, we are falling back to the example of the Dropbox, because we are used to it and we see these features directly, we have used those features, right. One is that it is independence, like from the connectivity and things like that. So, means that the local device must be able to provide service without continuous connection to the internet. So, it is independent, like you have some file in the Dropbox, you work on that file, even the connection is not there, still you can work. And collaboration means the application must be able to connect to the cloud service and synchronize with the data when appropriate things are there, right. It should be done on a means sort of a automated mode, quote unquote automated mode. You do not have to forcefully sync, you may opt for that options like forcefully syncs. Additionally, there can be a lot of other things which we can enable, like what we say sharing of the data based on some role based control, right. So, we can share with some or say role or rule based accesses, right. I say that this for this share at all those things. So, as we discussed, dew reflects the natural phenomena. Clouds are far from the ground, fog is closer to the ground, and dew is on the ground, right. Analogically, cloud computing is remote service, fog computing beside the user, and dew computing at the user system or user premise or user end itself, right. So, that it attempts to give those type of service. So, there are several model and some of the typical applications, like one is infrastructure as dew, like local device is dynamically supported by the cloud services like iCloud and things like that, which is a infrastructure as a dew, sometimes known as IAD. Software in dew, right, the configuration and ownership of the software are saved in that particular platform. So, that is saved in the means cloud, whereas this we have those things at the like typical example are your Google Play Store or App Store, and these are the things which are there. Platform in dew, a software development suite must be installed on the local device with the settings and application data synchronized to the cloud services. So, GitHub is one such example, which are we are using this sort of infrastructure. There are other service models like storage, like what you in dew, like storage of local devices partially or fully copied to the cloud, right. So, one is the Dropbox, Google Drive, these are some of the examples. And web in dew, a local device must possesses a duplicated fraction of the www or World Wide Web, that is the web in what we consider means is the web in dew, right. So, these are the several applications or several service models which Dew computing paradigms try to leverage on, right. So, what we see considering this, so I have several services like storage, platform, software, infrastructure, along with that web in Dew, or you can have your own other type of applications which you can have that on realized on the Dew platform. So, now looking at the broad architecture, so what we see, one side what we require is the cloud, right. So, which need to be synced with a either a single hybrid P2P communication link, which whenever the connection is there, it is there. Other side you have IoT devices and sensors where the data are being collected, right. And you have a Dew framework in your host system, often referred to as Dew virtual machine or DVM, right. In some of the literature you will find that Dew virtual machine, which must have a Dew server, which is the core of the thing. Along with that, there is a Dew client program which interacts with the client. There can be a Dew DBMS, which Dew database, which helps in storing the data in a more organized way, and there are Dew client services which provide services to the thing. There can be some of the other things, like in some places you will see that there are some of the means intelligent tools and techniques which takes care of the things. There are because it need to learn that what sort of the data access and configure the things at the Dew end, right. So, there are different module AI module or other things may come, but these are the things what we expect that the Dew will have. So, one is that interfacing with the client services, another is that server do sync with the cloud server based on the connectivity and the type of data being exchanged and this need of the data of the exchange, etc. So, to establish a cloud Dew architecture on a local machine, a Dew virtual machine is needed, right. Some sort of a this Dew virtual machine or Dew that particular Dew system need to be installed. Like what we do, we need to install the Dropbox at our end, right. And DVM is an isolated environment for executing the Dew server on the local system. So, it is a isolated independent environment, right, to run the Dew server at the local system. It has the capability of syncing with the other end cloud system, right. So, if you look at the basic function of the Dew server, to serve user with the requested services through that client services module and things like that, and to perform synchronization and correlate between the local data and remote data, right. So, to perform the synchronization and correlate between the local data and the remote data. So, these are the things which are by the Dew server. To attempt to achieve three goals, one is data replication, data distribution and synchronization, right. So, these are the things it attempt to look at it. So, need to serve the user end and need to synchronize at the other end, right. So, this is the one of the means basic goal of the things. There are other housekeeping work, like based on if the data is being especially in case of a storage, it is the data is being changing or being updated, deleted things. So, how overall organization will be data organization within the Dew database or data repository has to be looked into, right. So, those are the things which the server takes care. So, now let us see some of the categories or broad application areas, right. So, one is the web in the Dew, like possesses a duplicate fraction of the World Wide Web or a modified copy of the fraction to satisfy the independence feature, right. So, because this fraction synchronizes with the web, it satisfies the collaboration between feature of the DIU computing, right. So, this is one of the aspects which need to support, like web in the DIU is one category, like you have a fraction of the World Wide Web into your local systems which you need to work on it. There are storage in the DIU, already we have seen that the storage of the local device is partially or fully copied to the cloud, right, based on the things need to be copied. Since the user can access the files at any time without the need of constant internet connection or connectivity, the category, this particular category or application area meets the independence feature of the DIU computing, right. Storage in DIU or SID also meets the collaboration feature, because the folder and its contents automatically synchronize with the cloud service as we are discussing. So, it is both independence and collaborating features what we see is there, whereas in the web though it is synchronized with the web in the WID also it synchronized with the web and it satisfies the collaboration feature of the DIU. The other thing is the database in DIU. The local device and the cloud both store copies of the same database, right. So, one of these two databases is considered the main version and can be defined as such the database administrator, which is the primary version of the database, and where other one which need to be synced. This service increases reliability of a database, as one of the databases can be act as a backup to the other. So, by default it has a backup server DB server of the system it works at. So, we have web in DIU, storage in DIU, database in DIU, right. So, these are the typical scenarios what we are there. There are a few more. One is software in DIU, as we are as we seen in the couple of slides before. So, the configuration and ownership of the software are saved in the cloud, right. So, examples include this Apple App Store or Google Play, where the application the user installs are saved to their accounts, can be installed on any device linked to their account, right. So, this is the way it works, right. So, it is a software in the DIU. There can be platform in the DIU, like software development suite must be installed on the local device with the settings and application data synchronized to the cloud service. It must be able to synchronize the development data, data deployment, the system deployment data and online backups. So, like one example, those who are working with GitHub may find this thing very natural what you are doing, right. Like it should be must be able to synchronize development data, system deployment data and online backups. So, that is that what we say platform in DIU, right, or PID. And finally, the infrastructure as DIU or IAD, local device are dynamically supported by the cloud services, right. IAD can come in different form, but there are some of the popular forms. The local device can have exact duplicate DVM, like what we have discussed, that is DIU virtual machine instant in the cloud, which is always kept in the same state at the local instance whenever the connectivity is there, or it can be the local device can have all its settings data saved in the cloud, including system setting data and data for each application. So, it depends on how things works, but we can have that infrastructure as a DIU. So, what we see that there are different categories of DIU computing paradigm, starting from infrastructure, platform software and also things like that web in DIU, storage in DIU and database in DIU. So, there are several categories what we can see into this type of applications. So, what are there are challenges, or there are several challenges thing. One is definitely the power management, right. So, what should be the if based on your different categories and application area, how the power management is done is definitely a serious challenge, right. Other thing is the processor utility. like as on the local system. So, it is using the processor along with other services. So, what is the processor utility is makes a important aspects, right. So, other is the data storage, like because you need to store the data and also need to sync with the cloud. So, there are different issues, like especially how much data you have subscribed to, and also how much data you require from the local infrastructure or local system. So, those are need to be appropriately looked into. Not only having the subscription on the cloud storage, but also you need to have equivalent things maybe in the local systems, right. As such, it is not very challenging if you have a laptop or desktop, but it may be challenging when you are using the same thing in some of the low resource devices, right. Like it may be even mobile devices or other type of devices when you are using, then it may be a say smartwatch or so that may be a challenge. Viability of the operating system. So, based where the your Dew virtual machine is running. So, what sort of operating system underlining you it supports or it can run on is there. Programming principles, that is also another challenge, that how much configurable or how much what type of services you can provide based on the thing. And also it comes as a also definitely a security on information or database security is a concern, because it is now exposed to the that system and other services can whether it can access this data and others means Dew data, the data stored in the Dew or not, those are the things. So, that is there. So, these are some of the challenges where Dew computing paradigm what the Dew computing paradigm faces while providing flexibility in terms of independence and collaboration, things like that, right. And now, if we again come back to this big picture where the Dew enabled computing may be helpful one. So, if you look at the whole stack, so at the top we have the cloud server, then we have actually we can have fog servers, or here we refer to as edge servers. So, fog devices, then we can have edge devices, smart devices and smart IoT modules, right. So, these are the different layers of or hierarchy of this different type of category of servers and systems, right. So, Dew enabled computing can be realized at the lower hierarchy, starting from edge to smart device to smart IoT modules. So, at this end we can enable this thing in the Dew computing. So, those still work when the connectivity is not there, right. So, based on that last synchronized data, it can work and you can update and work on the things and get the services whatever is there, and then sync with the upper layers as and when the connectivity is available. Okay. So, so this what we see, that is the overall how you play a big a platform on the things. So, what we try to look into today's discussion is that whether we can bring down the computing. Already we brought down to this fog, we have seen that how fog and edge. Now, bringing to the ground, that means to the device level, where it can provide some independent services or provide some independent microservices, irrespective whether the connectivity is there or not, right. So, it facilitates the end users with a continuous service provisioning, right, that is important, like it provides the services even if the connectivity is not there. And on the other hand, whenever the connectivity is there, it allows to sync with the cloud infrastructure. So, that is a one good part of this or one advantage of this DU computing, and it can be enabled at the lower levels with this DU with this particular philosophy of DU computing paradigm. Okay. So, with this let us end our discussion, today's discussion. There are a few references. So, you may have a look on those references, right. And so, let us conclude our discussion. We will continue with other aspects of cloud computing in our next class. Thank you.